The normal sampling distribution models can be used to run tests of significance for population parameters such as p or mu. These are also known as hypothesis tests. The test assumes a value for our population parameter, and this assumed value is expressed as what we call a null hypothesis. Our sample statistic is compared to the assumed value to calculate a z-score. We call that z-score a test statistic. Once our test stat is calculated, normal probability can be used to obtain what's called a p-value. When our test statistic is relatively high, as we've seen, the probability or p-value will be low. Below we could see that z is only about 1.054, which here means that our p-hat value is relatively close to the assumed value of 0.5. We can easily use our Excel tool, Probability and Intro to Inference, to run z-tests for either proportion or the mean. Let's begin with proportion. We would need to input the variable number, here number 4 for gender, as well as a success category or the category of interest, which is going to be used to determine our p-hat. Next, on the Worksheet tab z-test for proportion, we would input a test value for that assumed value of p, here 0.5. Once the z-test statistic and p-value are calculated, we could make a decision regarding the null hypothesis. Our null will either be rejected or not rejected. The level of significance alpha helps us make a decision. Alpha represents what we call a rejection region on our sampling distribution and is often based on our familiar 5%. If the p-value is less than alpha, the null hypothesis is always rejected. Since we're working with the most extreme 5% of our normal curve, a critical point on that normal curve is plus minus 1.96. When our sample statistic, such as p-hat, has a z-score beyond 1.96, the p-value must be less than alpha. So if the z-test statistic is beyond 1.96, we always reject the null. Note that we are dividing alpha in half with 2.5% in each of the upper and lower tails. This is known as a two-tailed test. To calculate our two-tailed p-value, we would take our one-tailed p-value and simply double it. Here we could see the p-value is about 29%. This means that if we assume 50% women in the entire population, a little bit more than 29% of the time we should get p-hat values at least as extreme as 0.5505. Whether or not the null is rejected, a confidence interval can be used to estimate the value for our population parameter. Confidence level is measured as 1 minus alpha. We are 95% confident that the true value for p is within the range of the interval. In order to be 95% confident, we would need a range equal to p-hat plus minus 1.96 standard errors. When the test value or assumed value for our population parameter is in the range of the interval, the null hypothesis is not rejected. To run a test of significance, we follow the same basic steps in nearly every case. For example, currently the credit card company assumes that the population of credit card holders is about 50% men and 50% women. Step 1 would be to formulate null and alternative hypotheses. We want to test the validity of the assumption of 0.5, so we make that our null hypothesis. Step 2 is using our sample data to calculate a p-hat value and standard error. We could use that to obtain results. Here, our z-test statistic of 1.054 and our p-value two-tailed of 0.2921. The next step is to make a decision about the null hypothesis. Here our decision would be do not reject because the p-value is greater than 0.05. And as we can see, our test statistic is nowhere close to the required 1.96. Finally, we could make an estimate about the true population proportion using our confidence interval and state a conclusion, such as the percentage of men and women can still be close to about 50-50. Let's go to our Excel tool now to practice running our z-test for population proportion. Beginning on the data page, we would need to specify variable number 4 for gender. And our success category, or the category that's going to determine our p-hat, is F. The rest is set up and our results on the z-test for proportion. Tapping on that worksheet, we first need to formulate the null and alternative hypotheses. Simply by inputting the test value or assumed value for p of 0.5, we can see our results. So our p-hat value of 0.5505 is 1.054 standard errors above 0.5. We can see that's nowhere close to the required 1.96 to achieve statistical significance. As we would expect, in this case, our p-value is well greater than the required 5% alpha. Remember, we only reject the null when the p-value is less than alpha or our test statistic is beyond 1.96. Our spreadsheet tells us no, do not reject the null hypothesis at this level of significance. We are 95% confident that the true population proportion of women is somewhere between about 46% and 64%. And we could see that the test value for p, 0.5, is well within that range. Let's try another z-test for the population proportion. The credit card company currently assumes that about 50% of its entire market has an undergraduate degree. Answer the following. First, what would be the correct null and alternative hypotheses? Well, if the company currently assumes 50%, we're going to make that our null hypothesis. If we can reject that, we would conclude in favor of the alternative, or not equal to 50%. Let's go to our Excel tool to set up a test for education level. Remember, we're using our z-test and confidence interval for proportion. Our variable number 5 is education level, and the category of interest is BA, which is our undergraduate category. We set up our null and alternative hypothesis on the worksheet z-test for proportion, and we would input the assumed value of 0.5. What are the test results? When considering test results, we're always looking for the test statistic and the p-value. Here our test stat is a very strong 2.23, which makes our two-tailed p-value only 0.0276. On our spreadsheet, our test statistic and p-value are easily obtained. We can see that our p-value is less than alpha, and our test statistic is beyond the required 1.96. What is the decision about the null hypothesis? In this case, the null is rejected in favor of the alternative. Our spreadsheet will tell us should the null be rejected or not, but we could easily make that decision ourselves by comparing the test stat to that required 1.96, or our two-tailed p-value to our level of significance alpha of 5%. Using 95% confidence, estimate the population proportion of undergrads. we would say that we're about 95% confident that the population proportion of undergrads is somewhere in the range 51.4% all the way up to 69.7%. On our spreadsheet, our confidence interval is easily obtained. Further, we could see that 0.5, the test value for our proportion, is not within the range of the confidence interval. When we exclude that test value from our 95% confidence range, we would always reject the null hypothesis at the 5% level of significance. We can also use z-procedures to run significance tests for the population mean. Once again, the normal sampling distribution is used, only now we would need an assumed value for mu, the population mean. Using our normal curve, a two-tailed p-value is calculated for our test statistic. If that z-test statistic is beyond the required 1.96, our sample mean relative to that assumed value would be in the alpha region, or the rejection region of our sampling distribution, and the null hypothesis would be rejected in favor of the alternative. Using our Excel tool, Probability and Intro to Inference, we could easily run a z-test for a single population mean. We would only need to specify the variable number and an assumed value for sigma, the population standard deviation. Here, we're running a test of variable number 1, which is income, and we're assuming a value for sigma equal to 45. The rest is done on the Worksheet tab z-test for the mean, where we would input the assumed value for mu being used in our test. For example, testing income. The credit card company currently assumes that the population mean income is about $125,000. They also assume from prior data analysis that a good estimate of the standard deviation is 45,000. Let's follow our steps for running a z-test. First, we would formulate null and alternative hypotheses. If we would like to test the assumption of 125 for a population mean, that becomes our null hypothesis. If we reject that null of mu equals 125, we conclude alternatively that mu is not equal to 125. Step 2, results. Results are always our test statistic and our p-value. And here we could see our results are statistically significant. So our decision would be to reject the null hypothesis that mu is 125. We conclude alternatively that it is not equal to 125 and somewhere in the range of our confidence interval. Let's go to our Excel tool now to practice running our z-test and confidence interval for the population mean, and then we can discuss the results. Remember, to run a test for a quantitative variable, we only need the variable number. Here we're testing income, which is variable number 1. Our data are already in thousands of dollars. So to enter the assumed value for sigma of 45,000, we would only need to input 45. The rest is done on the Worksheet tab z-test for the mean, which is where we would first formulate the null hypothesis. We're testing a population mean of 125. Our results are statistically significant. We could see that our sample mean of 133.872 is 2.058 standard errors above 125. This is beyond the required 1.96. In other words, if we assume a population mean of 125,000, our sample mean is rather unlikely to occur at random. Our p-value is 0.0396, which is less than the required 5% level of significance. Remember, when the p-value is less than alpha, we reject the null. Our 95% confidence interval allows us to make an estimate about the population mean. We would say we're 95% confident that the true population mean income is somewhere in the range 125.42 up to 142.32. We can see that 125 is not within that range. This will always happen when the null hypothesis is rejected. However, we can see that the lower limit of our confidence range is rather close to 125. So though we are rejecting the null hypothesis, we are not strongly rejecting it. Let's run another z-test for the population mean and practice discussing the results. The credit card company currently assumes that the average spending per cardholder is about $4,000. They further assume that the standard deviation is 1,000. But lately, spending seems to have increased, and they would like to know if this change is statistically significant. We're using alpha equal to 5% for our level of significance. Step 1. What would be the correct null and alternative hypotheses? Well, if they currently assume $4,000, that's the value being tested, and that would be our null hypothesis. If we could reject that null, we would conclude alternatively that the mean has changed. Using our spreadsheet, we would run a z-test and confidence interval for the population mean. Spending is variable number 3, and our assumed value for sigma is $1,000. The rest is done on the z-test for the mean worksheet, where we would begin by inputting that assumed value of 4,000 for mu. What are the results? That is, what is the z-test statistic and p-value? When we ask for test results, we're always looking for the test statistic and the p-value. Here we could see our z-test statistic is only 1.275 and nowhere close to the required 1.96 for statistical significance. Accordingly, our p-value is high, over 20%. On our spreadsheet, we can see our sample mean, 4122, is in fact greater than 4,000. We might wrongly conclude that spending therefore has increased. However, it's very likely that we get a sample mean of 4122 or more when the population mean is 4,000. Remember, our p-value measures the probability of getting our sample mean by luck, assuming the null hypothesis to be true. In other words, about 1 in 5 samples of 109 can give us a sample mean like ours when 4,000 is perfectly true and correct. Therefore, our decision would be do not reject the null hypothesis. While our single sample mean is in fact greater than 4,000, this is a change that's easily attributed to random chance. In other words, it's not statistically significant. And finally, whether or not the null is rejected, we can make a confidence interval estimate about the population mean. Using 95%, we would say that we are 95% confident that the population mean is somewhere in the range 3934 to about 4309. And we could see that 4,000, our test value for mu, is well within that range. Remember, when our assumed value is in the range of our confidence interval, we do not reject the null.